Hello, everyone! Have you ever wondered why water sparkles or twinkles when sunlight hits it, or a spoon appearing bent when placed in water? These phenomena are all due to the principles of light reflection and refraction. Today, we'll learn about these two fascinating properties and explore how mirrors and lenses are used in our daily lives. First, let's talk about light reflection. When light hits a smooth surface, it bounces off in a different direction. This is what we call reflection. A common example of this is a mirror. When light reflects, it enters the surface at a specific angle, called the angle of incidence. This angle is always equal to the angle at which it bounces off, known as the angle of reflection. For example, car rearview mirrors use this principle to help drivers see behind them. If you can't see clearly, simply adjust the angle of the rearview mirror to change the angle of incidence, and the reflection will adjust accordingly. There are three main types of mirrors. Flat mirrors. Flat mirrors are the most common type of mirror. They reflect images that are identical in size and distance to the actual object, but flipped horizontally. For example, when you move your right hand, it looks like your left hand is moving in the mirror. Convex mirrors. A convex mirror has a surface that curves outward, like the back of a spoon. This shape spreads light, allowing it to reflect a wider area and make objects appear smaller. It's commonly used in car side mirrors and security cameras. Concave mirrors. A concave mirror has a surface that curves inward, like the inside of a bowl. This shape focuses light to a single point, making objects appear larger and more detailed. Concave mirrors are used in makeup mirrors and car headlights. Mirrors are selected and used depending on their purpose. For example, in a clothing store, both convex and concave mirrors are used for different purposes. Convex mirrors are often placed on walls to make the store look more spacious, while concave mirrors are commonly used in fitting rooms to create a flattering reflection of the customer. Now, let's talk about light refraction. Refraction occurs when light passes from one medium, like air, into another medium, like water or glass, where its speed changes, causing it to bend. For example, have you ever noticed a submerged object, like a straw, appearing bent in water? This isn't because the object is actually bent, but because light travels at different speeds through different mediums, creating this effect. The degree to which light bends is measured by a value called the refractive index. Different materials have different refractive indices, which cause light to bend by varying amounts. Here's an interesting fact. Materials with a high refractive index can bend light significantly, creating unique optical effects. A great example are diamonds. Diamonds have an exceptionally high refractive index, causing light to bend multiple times within them. This bending of light creates their dazzling sparkle under sunlight or artificial lighting. Lenses are tools that use refraction, and they can be divided into two main types. Convex lenses. These lenses are thicker in the middle and focus light to a single point. They are used in magnifying glasses, microscopes, telescopes, and camera lenses. Concave lenses. Concave lenses are thinner in the middle and spread light out, making them useful for correcting vision problems. Eye astigmatism, for example, occurs when the cornea has an irregular shape, causing light to focus unevenly on the retina. By spreading light in the right way, concave lenses help focus it correctly onto the retina, improving vision clarity and reducing distortion. One of the best ways to observe refraction is by using a prism. A prism is a transparent object, typically made of glass or plastic, with flat, polished surfaces that bend and disperse light. White light, such as sunlight, may seem like a single color, but it is actually made up of many colors. As it passes through a prism, each color bends at a slightly different angle because of its unique refractive index. When light passes through a prism, it bends and separates into the colors of the rainbow, a phenomenon called dispersion. For example, red light has the longest wavelength and the lowest refractive index, so it bends the least. On the other hand, violet light has the shortest wavelength and the highest refractive index, causing it to bend the most. This difference in bending angles creates the beautiful spectrum of colors we know as the rainbow: red, orange, yellow, green, blue, indigo, and violet. Today, we explored light reflection and refraction and learned how they are applied in our daily lives. These concepts may sound complex, but they're actually all around us, playing a key role in many everyday objects and phenomena. Next time, I'll show you some simple experiments that demonstrate these principles in action. Take some time to think about what we've explored today, and I'll see you next time. Thank you for watching.